Here we're going to review prime factorization. We've done this before, but we need to review it because it is a very important skill to have in maths. You must be able to find the prime factors of any number up to 360. And over the next few weeks, we are going to test to see that you can actually do that. You must be able to find the prime factors of any number up to 360. And those of you who are very serious and conscientious, start on that. Check yourself, test yourself, and make sure you can. What do we mean by prime factorization? Let's do a bit of a review here. Here we have our set of prime numbers. You know the prime numbers start with 2. You should know that 1 is not a prime number because prime numbers have 2 factors only, 1 in itself, and the number 1 only has 1 factor. So 1 is not a prime number. The prime numbers start at 2. And then after that, the prime numbers are only odd numbers, not every odd number, certain odd numbers that only have 2 factors. So set P above here is the set of prime numbers, and you know this here is called an ellipsis, which tells us that the numbers continue. We only use prime numbers for prime factorization. If the number we want to factorize is an even number, then when it comes to prime factorization, we start with the number 2. If it's not an even number, we factorize with 3 if possible, or 5 if possible, and so on, i.e. always using the smallest prime number. So what are we saying here? When it comes to prime factorization, please pay attention. It means that we are always going to check first, is the number that we want to factorize an even number? If it is, we're going to start prime factorizing it by dividing it by 2. If it's not an even number, then we're going to see, well, can 3 go into the number? If 3 can't, then we'll try 5, 7, like that, always using the smallest possible prime number to divide our number. So what does it look like? Look at this. Here, for example, we are going to find the prime factors of these 2 numbers here, 72. The first thing I did was to check, is it an even number? Yes, it's an even number because you know here it ends in an even number. So I'm going to start with 2. So I write in my box here, in my cross box, 2 and 72. 72 is the number that we're finding the prime factors of, and 2 is the first number I'm going to divide by. So that's the first prime factor I'm going to use. So how many 2's are there in 72? Well, if you can't do it in your mind, there's no problem. You can just do it in a division box. In fact, unless you're very comfortable and confident, just do it in the division box. You have nothing to lose by doing that. How many 2's are there in 7? 3. How many 2's are there in 12? 6. And that's how I got to have the 36. So once I've got my 36 here, I realize 36 is still an even number, so I'm going to use 2 again. How many 2's in 36? 18. So I write the 18 here, and I check. It's still an even number, so I'm going to divide by 2 again. And this time the answer is 9. Well, 9 is not an even number, so I go to 3. Can 3 go into 9? Yes, it can. So I'm using 3. 3 goes how many times? 3 times. So that's my answer. Then again, 3 will go into itself once. And we keep going until we get to 1. We know that 1 is not a prime number. And then we can just look at our prime factors here. They will be on the left side of the table. So in this case, we had 2 times 2 times 2 times 3 times 3. And we can write that in index form, which is 2 to the power of 3 times 3 to the power of 2. Let's go over here to the right and look at this example. Let's clear up some of the mess that we've made. So this time our number is 105. And what I want you to realize is that 105 is not an even number. And so I'm not going to try dividing it by 2. But I will try the next smallest prime number, which is 3. Can 3 go into 105? Yes, it can. How do I know? Well, you should know how you can tell if 3 can go into any number. I'm not going to go into that now, but there's an easy way of telling, which we're going to go over in the future. But I do know that 3 will go in here. So 3 will go into 105. How many times? Well, as I said, you don't have to do this in your mind. You can just draw your division box. How many 3's in 1? 0. Can't go. How many 3's in 10? 3. Remainder 1. How many 3's in 15? 5. So that is how I got my 35. Well, Then I look again and I realize 3 cannot go into 35. 2 can, of course. So the next number to try is 5. How many 5s in 35? 7. What number am I going to use next? Well, 7. How many 7s in 7? And the answer is 1. When we get to 1 here, it means we finished our work, and our prime factors are going to be on this side here. So 3 times 5 times 7 is what it is. Good. Now we've done that fairly quickly because it is a revision. So here's your